Finding area of irregular figures. Here's our lesson frame for today. We will decompose figures to calculate the area. You will use strategies like multiplication to determine the area of figures. I always like to find how we can connect this to real life, the real world things we might be doing. And this picture made me think of a home. So if you have ever been in the process of looking at blueprints, is what they call them, of a home or a building, you'll notice that they look like this. They tend to look like just, little drawings, square drawings on paper. If you are interested in being an architect or building or designing things, you will have to be able to look at an irregular figure on a piece of paper to determine the area of it, similar to a blueprint of a home. Let's review. Here is one of my irregular figures. It's two rectangles put together, and we can cut it two different ways to break it down into smaller rectangles. So here's the first way, and this is what I went with, or you could also cut it this way. So it's not important how you cut it, it's about finding the area. So if I cut it this way, I have a length of 3 and a width of 7. 3 times 7 equals 21. On rectangle of 2, I have a length of 3 and a width of 3. 3 times 3 equals 9. So that means my top rectangle has an area of 21 square units, and my bottom rectangle has an area of 9 square units. If I add them together, 21 plus 9, that equals 30 square units. So my entire figure here, the whole thing, has an area of 30 square units. Now, if I wanted to double check, I could always count all of my units, or for some reason, if I didn't have all the units, I could even take it and draw those lines in to represent those units myself. So we do have some options to double check our work. Don't forget, decompose is just the mathematical way of saying break apart. We decompose numbers, we can decompose shapes. We can break apart numbers, we can break apart shapes. Let's practice. You're going to decompose the figure into rectangles. You're going to find the area by showing your multiplication and addition equations. Go ahead and pause the video now and solve, and then you can press play to hear the answer. All right, I hope you solved. Let's find the answer together. If you haven't solved, pause now and solve. All right, here we go. Here is how I am going to decompose my rectangle. I have rectangle 1 and rectangle 2. Rectangle 1 has a width of 3 and a length of 4. 3 times 4 equals 12. So rectangle 1 has an area of 12 square units. If I counted all these squares up, I would have 12 squares. Rectangle 2 has a length of 4 and a width of 4. Lots of 4s there. 4 times 4 equals 16. Rectangle 2 has an area of 16 square units. 16 plus 12 equals 28, which means this entire rectangle has an area of 28 square units. Here's another one. Let's break apart the figure into rectangles. Remember, there's two ways you could break this one apart. You can decide which way you're going to try, and then I'll show you which way I'm going to try. Go ahead and pause now, and after you solve on your own, I want you to click play, and we'll go through this together. All right, here is that irregular figure, or those combined rectangles. I'm going to break them apart up and down. I'll have rectangle 1 and rectangle 2. Rectangle 1 has a width of 3 and a length of 4. 3 times 4 equals 12. So rectangle 1 has an area of 12 square units. Rectangle 2 has a length of 6 and a width of 2. 6 times 2 equals 12. So rectangle 2 has an area of 12 square units. 12 plus 12 equals 24. So altogether, this shape has an area of 24 square units. Something I want to point out is rectangle 1 and rectangle 2 both have an area of 12 square units. If you don't believe me, you can count to double check. However, they both look different. Rectangle 1 looks taller and skinnier, where rectangle 2 looks longer and fatter. So, even though they look very different, they could have the same area. Let's determine the area of this shape. Go ahead and pause now and see if you can determine on your own, and then click play to check with me. This is a challenge. Remember, you can decompose it as many ways as you need to. It's about making it easier to calculate. There's not a right or wrong way to decompose. You can actually decompose it as many times as you need to, so different ways and however many different pieces you need. It's not about how many ways, which way you decompose it. It's just about making it easier to solve. I'm going to make this rectangle 1. I'll make this middle section rectangle 2, and I'll make my far right section rectangle 3. Rectangle 1 has a length of 6 and a width of 3. 6 times 3 equals 18, so rectangle 1 has an area of 18 square units. Rectangle 2 has a length of 3 and a width of 5. 3 times 5 equals 15, so rectangle 2 has an area of 15 square units. And rectangle 3 has a width of 3 and a length of 7. 3 times 7 equals 21. So rectangle 3 has an area of 21 square units. If I add these together, I will find that my entire figure has an area of 54 square units. So all together, it's 54 square units. All right, let's practice. Shelley drew a diagram of her backyard on grid paper. Each unit square is 1 square meter. The area surrounding the patio is grass. How many square meters of grass are in her backyard? So here's her backyard. How many rectangles could you decompose this into? What would make this easier to solve? What would be the equations or the multiplication sentences you would use to solve? You can pause now and solve. The correct answer is letter C, 26 square meters. Here's a challenge. Diane is building a backyard pond and garden. She draws her design on grid paper. Each unit square is 1 square foot. The blue squares are pond and the green squares are garden. How many more square feet of garden are there than square feet of pond? I know 2 things. I know my students know what how many more means. And I know you know how to find area. So we're taking those 2 things we've learned in separate units and putting them together. Go ahead and pause for a second, solve, and then we'll check together. First, you have to decompose the figure into pond. Solve for the area of pond. With a length of 2 and a width of 4 will give us an area of 8 square units. Now the garden, the area of the garden is a length of 4 and a width of 4, which gives us an area of 16 square units. But should we add? Did they say what is the total area of the garden and pond? Or did they say how many more? How many more is a trigger phrase, and you should go, whoa, whoa, whoa. The question is asking how many more square feet of the garden are there than square feet of the pond? What operation do we need to solve? If you said subtract, you are correct, because we want to know how many more. This is a comparison. 16 take away 8 equals 8. So the garden is 8 more square feet than the pond. Very good. You did awesome today. Now, a few things I want to point out is in our Google Classroom, I posted graph paper. You saw me use graph paper on our Friday lesson. A lot of what we've been doing with our shapes looks like there's graph paper inside. Graph paper is a tool that you can use when solving for area. I have posted graph paper in our Google Classroom if you would like to use it as well. Thank you guys.